In this video, we want to find the limit as n approaches infinity of this summation. So this comes from a definition of an integral. So if you recall, it's going to be limit as n approaches infinity f of a plus delta xi times delta x. So delta x is always b minus a over n. And for this problem, that is 2 over n. That means b minus a is equal to 2, and a has to equal 1. So that makes b equal 3. My function is just a cube, so f of x is x cubed. So what this is saying is take the integral from 1 to 3 of x cubed dx. And so when I find the antiderivative, I get x to the 4th over 4. Plug in 3, it's 81 over 4. Then minus plug in 1 over 4. This is 80 over 4, which is 20. Okay, so I should get 20 as my answer. Okay, so let's look at the student's work and see where they made a mistake so we can correct this. So they start off correct here. And the second step was just cubing the 1 plus 2i over n. So to help you out, a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. So this was done correctly, and the student factored out a 2 over n because it did not depend on I. Okay, so everything that's I has to stay inside. 2 over n is being multiplied, so this is basically a constant, so you can pull it out of the summation. Okay, so this is good so far. And at this point, the student broke this up into 4 separate sums, which is good. And then because the summation, the variable here, or the index is I, you can factor out the 8 over n cubed and the rest. So 8 over n cubed, and then 12 over n squared, 6 over n. Those get factored out. And then the last one here, you're summing up 1 from I equals 1 to n. So when I equals 1, you get 1. When I equals 2, you get 1. All the way up to I equals n, you get 1. So you're adding 1 n times. So that's just n. So this is correct. And the next thing the student does is use formulas. So these are just the formulas for I cubed, I squared, and I. So these are all correct. Okay, going down, the student FOILed out the n plus 1 squared and then distributed the n squared. And then same thing here, FOILed it out, FOILed it out. So this is all correct so far. And at this point, the student distributed the 8 and the n cubed for the first one, 12 over n squared for the second, 6 over n for the third. So far, everything is good. Okay, now this is where we run into trouble here. So this step is wrong. The thing is, we have 3 fractions and with all different denominators. So the goal here is to get a common denominator between them. So the denominators are 4n cubed, 6n squared, 2n. Now, you want to find the least common multiple of these. So for n's, we know it's going to be n cubed. Now you want to find the least common multiple of 4, 6, and 2. That's going to be 12. So I want to rewrite this with a denominator of 12 over n cubed. And I'm also going to do the last one, the n, as well. Okay, so let's think about this. For the first one, the first denominator is 4n cubed, so that means I have to multiply by 3 over 3. So 3 times 8 is 24. 3 times 6 is 48. 3 times 8 is 24. Okay, the next one is 6n squared. I need to multiply this by 2n over 2n. Okay, 2 times 24 is 48, and then I have n to the 4th. 36 times 2 is 72, n cubed. 2 times 12 is 24, and then n squared. This one, I have 2n. I need to multiply by 6n squared over 6n squared. That's going to give me 36n to the fourth plus 36n cubed. The last one, I need to multiply by 12n cubed over 12n cubed. And this will be 12n to the fourth. So of course, you still have the 2 over n and the limit as n approaches infinity. So we know that this is going to be all over 12n cubed, and then we just add. So starting with the n to the fourth. So we see there's multiples of 12 here. So if you want to make this easy, you can think of this as 12 times 2, 12 times 4, 12 times 3, 12 times 1. Add up 1, 3 is 4, plus 4 is 8, plus 2 is 10. 12 times 10 is 120. Okay, then we move on to 48, 72, 36. So this is 12 times 4, 12 times 6, and 12 times 3. 3 plus 6 is 9, plus 4 is 13. 13 times 12 is 156. The last one, we have 24n squared, 24n squared. So we can just add that. It's 48n squared. Then you have a 2 over n. The limit as n approaches infinity. So the 2 is going to cancel with this. This becomes 6. And then you can distribute the n with the n cubed. It will be n to the fourth. Now, because we're looking at n going to infinity, we can look at the horizontal asymptote, but instead you can, if you want to be precise, you can multiply everything by 1 over n to the fourth to get 120 plus 156 over n plus 48 over n squared all over 6. Now these will go to 0. I'm left with 120 over 6, and so this is equal to 20. And that's the answer that I wanted to get.